Now in its 27th year, the school year 2024 to 2025, the Philippine Mathematical Olympiad is the oldest and most reputable nationwide mathematics competition among high school students. After its trial run in 1984, it was officially launched in 1986 and has been held annually since 2007. The country's contestants to the International Mathematical Olympiad are chosen from the top students who compete in the Philippine Mathematical Olympiad. The PMO is a project of the Mathematical Society of the Philippines and the Department of Science and Technology Science Education Institute.
Good day. Welcome to another video of the PMO video series. My name is Immanuel Balete, and today we will be discussing Cartesian coordinates. Before that, let's take a look at the world map. It's interesting that every point on our globe can be identified using just two numbers. For example, here's the Philippines, and we can identify the approximate position of the Philippines by looking at its latitude and longitudes. For the latitude, so you'll see that from the equator, you move up around 12 degrees north. And then for the longitude, from the meridian, you move to the right around 125 degrees east. So with just those two numbers, 12 degrees north and 125 degrees east, or in this convention, positive 12, positive 125, you can mark the position of the Philippines. And this is the same idea used in Cartesian coordinates, except instead of a globe, we won't be thinking about a globe because that's a little more complicated, but we're just going to look at a flat infinite plane. So every point on the plane can be identified with two numbers, the x and the y coordinate. For example, this point here would be labeled as 2, 1. The first number is the x coordinate and the second is the y coordinate. So the x coordinate is the number of units you would travel along the x-axis, which is this horizontal line is our x-axis. And the second number is the number of units you travel along the y-axis, which is this vertical line. So you move 2 units right and 1 unit up. So that's why this point has the coordinates 2, 1. And similarly, you can identify the coordinates of any point in this plane. Now, one special point here is the point at 0, 0, which has a special name called the origin. So there. So using just two real numbers, you can uniquely identify every point on the Cartesian plane. And now, we're gonna focus, for this video, we're gonna focus on lines in the Cartesian system. So a line, let's draw a random line. Let's say this line. There. So this line can be, this line would be, okay, no, let's do a different line. This one's not quite exact. So let's do the line from here going here. Okay, there. I think that's better. So we'll put arrows here to indicate this is an infinite line. And we'll find, although we'll explain later how we get this, we'll find that this line is associated to the equation y equals 2x minus 1. And what do we mean by this line is associated with this equation? Well, what this means is for any point on the line, let's say this point here, 1, 1. So it has x coordinate 1 and y coordinate 1. And if you substitute x equals 1, y equals 1, you will find that it satisfies y equals 2x minus 1. Similarly, if you take this point over here, negative 1, negative 3, you will also find that if you substitute x equals negative 1 and y equals negative 3, that it also satisfies the equation y equals 2x minus 1. And indeed, any value of x and y which satisfies the equation lies on the line. So the points of the line are represented by that equation, y equals 2x minus 1. Now, given a line, how would we know what it's, so let's say you don't know the equation. So you're just told we have a line going through 1, 1, and -1, -3. How would we figure out what the equation of the line is? Well, we'll first we'd need to compute the slope. So the slope is a measure of how steep a line is. So the higher the slope, the steeper your line is. For example, it would look like this, more and more vertical. So it would be steeper. You can also have a negative slope, and negative slope is when your line, you can think of it as going downhill. So as you move from left to right, the line is going downwards. So those are lines with negative slope. And you can also have a line with zero slope. So perfectly vertical, just like our x-axis, it has zero slope. So what's the technical definition of the slope? Given 2 points, A, B, and C, D, so given 2 points with these coordinates, the slope is defined as the difference in their y coordinate divided by the difference in their x coordinate. And the idea, there's a mnemonic for this called rise over run. The idea is that you examine, you examine how much you change in the vertical direction divided by how much you changed in the horizontal direction. And you can think about this if you increase the rise. So if you change more in the vertical, then it gets steeper. If you increase the run a bit more, you can imagine that the slope gets a bit lower. So this is the definition of the slope. So for example, in this case, our points are 1, 1, and -1, -3. So their slope would be 1 minus -3. So we took the y coordinates, the difference of the y coordinates, divided by 1 minus -1, the difference of the x coordinates. So this is 4 over 2, or 2. So now that you have the slope, we know that this tells us that the form of the equation for the line should look like y equals 2x plus b for some constant. Oh no, we already used, yeah, for some constant b. Let's use a different variable. Let's say p. So the equation of the line should be y equals 2x plus p. Another way to think about this is when you know the slope of a line, then if you increase x by 1, so when x goes up by 1, the effect is that y goes up by 2. And you can also see this in the line, right? If your x moves forward by 1, the point on the line increases by 2. The y coordinate will increase by 2. All right, so now we just need to solve for p. And to do that, we can substitute our point and either of the points. So you know that x equals 1, y equals 1 should satisfy this equation. And if you substitute, you will find that p equals -1. So therefore, the equation of the line must be y equals 2x minus 1. And this is how you would identify the equation of a line given any 2 points on that line. Now we'll use this idea to solve some items from the PMO. So here's the first one from the 20th PMO. The line 2x plus ay passes through, they're given the points -2, -1, and 1b. So what is the value of b? So pause the video and try this out on your own first. All right. So we're given a line and we have two unknowns. Well, but based on what we discussed earlier, we know that these 2 points should satisfy the equation of the line. So if you substitute, let's do the first one, -2, -1. So if you substitute x equals 2 and y equals -1, then you'll get 2 times -2 plus a times -1 should be equal to 5. And from here, you can solve that a should be equal to -9. So now we can substitute the other point. So we have 1b. So 2 times 1 plus, well, now we know that a is -9. So a is -9, and then y is b. So 2 times 1 plus -9 times b is equal to 5. And something seems off. Oh no, this is correct. Okay, sorry, this is correct. Yes. So 2 minus 9b equals 5. And if you simplify, you should find that b is -1/3. So our answer is, also choice B, -1/3. Great. Let's look at another item from the recent PMO, the 27th PMO. A square is drawn in the plane whose vertices are the points 0, 0, 1, 0, 0, 1, 1, 1. All right, so let's draw that first. Let's take a look at that diagram. So it's very important to make a little sketch. So here's 0, 0. Let's say 1, 0 is over here. 0, 1 is over here. And then, oops, 1, 1 would be over here. This is 1, 1. So this is our square. And you want to draw the line y equals kx. Now you'll notice, if you try drawing y equals kx for some value of k, you'll observe that it's a line that passes through the origin, right? So that's a hint already for this item. It's a line passing through the origin because 0, 0 satisfies that equation. So it must look maybe something like this or something like this, okay? And it divides the square into 2 regions, with the area of the upper region being 27 times the area of the lower. So we want to find k. Now, pause the video again and try this out on your own. Okay, so we're told that the area of the upper region is bigger than the lower one, which means that we can somewhat guess that the line probably needs to look like this because we need the upper part to be bigger. And we know that the total area of the square is 1 because it has side 1. And if you want the upper region to have 27 times the area of the lower, then the area on top must be 27 divided by 28, while the area of the triangle at the bottom should be 1 over 28. So they still have a sum of 1. Okay. Now, how do we compute the area of this triangle in terms of k? It would be helpful to know what this point is, right? Because we already know that the triangle has a base of 1. But what is the red point here? Well, we know that the red point has an x-coordinate of 1. But we need to know the y-coordinate. But we also know it passes through the line y equals kx. So if you substitute x equals 1, then you get y equals k, which means the y-coordinate of this must be k, so that it will lie on the line y equals kx. Now that you know the y-coordinate is k, we know that the height of this triangle must also be k, which means the area of the triangle in terms of k is 1 times k over 2 equals 1 over 28, or k is equal to 1 over 14. So our answer is D, 1 over 14. Great. Now let's do one more item. So one last item from the 24th PMO this time. So there's a definition here. A lattice point is a point where both coordinates are integers. Find the number of lattice points that lie on the closed line segment whose endpoints are the points given. So again, pause the video, try it out on your own, and then continue when you're ready to hear the solution. This time, we're asked a different question. So we want to count number of lattice points. And we could try drawing what the figure looks like, although the numbers are pretty big. So we won't really make it to scale anymore. Let's just say that the numbers are pretty big. So let's say you have, so this is definitely not to scale. Let's say you have 2002, 2022, 2022 and 2202. So your first point is over here, and your second point is over here. Yeah, there's not really much to see here. It's really just a line segment connecting 2 points. What's more important to us is to know what the lattice points are. So since we're only interested in points where both coordinates are integers, essentially mm, you want to check what happens at x equals 2003, x equals 2004, all the way until x equals 2021, right? And we want to know, because those will appear somewhere along equidistantly on this line, right? You want to know if their y coordinate is also an integer or not, because maybe their y coordinate is some non-integer value. How can we check? We need to know the equation of the line segment. And remember, to get the equation of the line, we first compute the slope. So the slope is the difference in the y coordinate, the rise, divided by the difference in the x coordinate, which is the run. And this turns out to be 180 divided by 20, or 9. So the slope is 9, which means the equation of the line is y equals 9x plus some constant b. And we can compute for b by substituting one of the 2 points. So let's say you substitute x equals 2002 and y equals 2022. And this would be a pretty big number. Yeah, so you'd find that b is equal to 18018 minus 2022. Pretty big value. But what's important is we observe this is an integer. So we know for sure b is an integer. We don't have to note what this exact value is anymore, but we know that what's important is that this is an integer. All right, so as we said, we need to check what happens at x equals 2003, 2004, and so on. And when we substitute, we see that 9 times x, this is an integer, plus another integer. So the result must be an integer, which means no matter what integer x you substitute, you'll also get an integer for y. And thus, all of these would actually be valid lattice points. So these are all valid lattice points. And since we're asked about the closed line segment, we have to include the endpoints. So the endpoints are also counted, which means all in all, we just have to count how many points there are. And you're going from x equals 2002 to x equals 2022. And there's 1 point for each integer. And so if you count, that gives you 21 integers. So the answer is letter B, 21. And here ends our discussion on Cartesian lines. I hope you learned a lot and see you in the next video.